Okay, let's keep going. Number 10, it says express the area of the figure as a monomial. A monomial just means one term. So if we're looking for the area, it's a rectangle, so we know the formula for the area of a rectangle is length times width. So all we have to do is multiply the two sides together. So that means we have 5y squared times 3y cubed. So we will multiply our coefficients, but then we will add the exponents. So 5 times 3 will give us the 15, and y squared times y cubed will give us y to the 5th power. Okay, so number 11 says express the volume of the solid as a monomial. Again, as a one term, sorry. So the volume is just length times width times height. So I will multiply all three sides. So I will have, let me do it down here. I will have 3x to the 4th y to the 10th times 6x squared y cubed times 2x to the 5th y to the 9th. Okay, so if it helps, guys, you can rearrange, put all of your coefficients together, all of your x terms together, and then all of your y terms together. Just keep reminding yourself what law this is. So the coefficients, of course, we're just multiplying. So 3 times 6 is 18, and then 18 times 2 will give us 36. But when I have exponents, if my bases are the same and it's multiplication, I add the exponents. So I am going to have 4 plus 2, which is 6, plus 5 will be 11. And then my y's, I will have 10 plus 3, which is 13, plus 9, which gives us 22. Right, number 12 is asking us to express the decimal in scientific notation. So we need to move the decimal point to the right to where when we stop, we will have created a number that's between that number needs to be 1 or greater, but then less than 10. So let me keep going with my... I need to move right there. So it'll be 6.07 times 10. And then how many places did we go? We went 1, 2, 3, 4, 5, 6, 7 places. And it was a decimal, so it will be a -7. Okay, let's do the next one. Again, I'm trying to move my decimal point, which is starting right here. I'm going to go to the left, and wherever I stop, that number needs to be 1 or greater, but definitely less than 10. So that means I need to move it right here. So I will have 4.56 times 10 to the, this is 369, and it is a positive number. All right, number 14 is asking us to evaluate each product or quotient. And this is be a product, of course, and then express the results in both scientific notation and standard form. All right, so again, I'm going to rearrange. I'm putting my numbers together. I'll put an X there. So 2.2 times 7.7, and then I will have my bases of 10. Okay. So 2.8 times 7.7, and that's going to give me 21.56 times, and then bases are the same, and I'm multiplying, so what I do with the exponents, we add them. -4 plus 9 will give me a +5. Now let's look at what we have. We hope this is in scientific notation, but notice this number is bigger than 10, so I need to move my decimal point one place over to where now I have 2 point, sorry. Let's try that again. I have 2.156 times 10, and because I moved it one place this way, I need to add 1 to my exponent, so I will have 10 to the 6th power. So here this is in scientific notation, but it also said standard form, which means like just a regular number, right? So if I move this decimal point 6 places to the right, I should come up with my numbers. So I have, here it is, so I move it 1, 2, 3, but I need to go 6 places, so we're going to add 4, 5, 6. So this would be my answer in standard form. Okay, let's try the next one. This time I'm dividing. So again, we need to divide the numbers. So we have 8.1 divided by 1.8, and that will give me 4.5. Times 10 to the, and remember, what do we do with the exponents when it's division? We're going to subtract. So 4 minus a negative 4. So remember, keep, flip, change. So I have 4 plus 4, so that's going to end up being 8. So is this in scientific notation? This number is greater than 1 and less than 10, so I am good. And then if I write it in standard form, I'm going to move my decimal point 8 places to the right. So I'm going to say 4 and 5. My decimal point started there. There's 1, so I need to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. And then I can put my commas in there. And there my answer would be in standard form. All right, so we're going to simplify. I can do a couple of different things. I can simplify from this form. I could have written it in radical form, where the 64 is under here, the root is 6, and I'm raising it to the 5th power. But it is just saying to simplify, so we can just go to our calculator. Let me pull that up. And hang on, I wanted to write. So the problem originally was 64 to the 5 over 6 exponent, right? Okay. Let me move this over a little bit. There, so now we can see all the calculator. Okay, so let's see what we're going to do. I just need to type in, let's go to Scratchpad. Okay, I'm going to add a calculator. Alright, so I'm going to have 64, and I want to raise, have an exponent, so I'm going to hit my little caret button over here, and then my exponent is 5 over 6, so I'm going to change that to a fraction, and then put 5, arrow down 6, and then hit enter, and there's my answer is 32. If you had changed it to look like this right here, we could have typed that in also, parentheses, and then control caret, and then 6 for my root, and then move it over and have 64 for under the radical, and then I need to raise this whole thing to the 5th power, so then I'd hit caret and then 5, and then hit enter, and I'll still have the same thing. This definitely was much easier. So if it's not asking you to write it in radical form, then don't. Just leave it and take care of it that way. Alright, so we said our answer for this one came out to be 32, right? Okay, same thing with this one, 81 and then to the 5 over 4 power. So let's flip back to my calculator. Let me clear. I'll clear it. No. Alright. Okay, so the problem was, sorry, I lost it. It was 81 to the 5 over 4 power, right? So I'm going to type in 81. I'm going to my caret button. I'm going to change that to a fraction. And then it was 5 over 4. Enter. So 243 would be the answer. $243. Okay. How about the square root of 128? So we know that's not a perfect square, so what we may need to do is simplify it. So what I'm going to do is write all the powers of 128. So 2 goes in at 64. 3 won't go. 4 will go. 32. Okay, so I've listed all the factors of 128. And now I'm looking to see which ones are perfect squares. So of course 1 is always a perfect square. 4 would be a perfect square. 16 is a perfect square. 64 is a perfect square. I need to go with the highest one. So 64 is it, right? So I'm going to have 64 times 2. And then 64 is a perfect square. So the square root of 64 is 8. And then I have 2 remaining, and that stays under my radical sign. Okay, let's try 72. If I list all the factors of 72, 1 times 72, 2 times 36, 3 times, I don't know, 24. 4 times 18, 6 times 12, 8 times 9. I think that's all. Okay, so let's try. Let's see. 1 definitely is a perfect square. 4 is a perfect square. 9 is a perfect square. 36 is a perfect square. So I believe we're going to go with the highest, which is 36. So I'm going to rewrite this as a multiplication problem. 36 times 2. 36, the square root of 36 is 6. 2 stays under the radical. And there's my answer. Okay, 20 and 21 is asking us just to rewrite it in radical form. So here's my radical sign. The 22 goes underneath. The root is this number right here. That's 3. And we're good. Let's try the next one. This is not in parentheses. So that means the whole thing does not go underneath my radical sign. Just the x. The root is 4. And I am multiplying it times 3. So 3 goes into the front. Okay, number 22, it says, write an equation to represent the following situation. Liam's profit Y for selling X bracelets for $5 each after spending $12 on supplies. Okay, so the profit is going to be Y. And we are selling X bracelets for $5 each, so that means $5 for each bracelet. After spending means I have to, I'm losing money, right? Or I'm not adding it, I'm spending it, so that means I'm subtracting $12. And there we go.